So, hello. Welcome to our Vision Channel session about AI-based quality inspection. My name is Heiko Seitz, and I will take you through today's topic. I think we can start now. Yeah, the topic, the control and assurance of product quality in production processes is a topic that concerns us in many areas. Manual visual inspections are often still used to detect scratches, cracks, or shape defects, and to ensure that defective products are safely sorted out before they go further to further processing or directly to our customers. But today, quality requirements can be transferred to AI-based vision systems through machine learning and to optimize and automate these processes. And I would like now to show you some possible use cases and also how the technology remains controllable through suitable tools. But before I go into the topic directly, something organizational. If you have any questions during or after the talk, then please use the Q&A section. I will then try to answer all your questions after the talk. Furthermore, you can also watch this webinar, the recording, again in a few days in the Vision channel on demand. And an additional information will be sent to you by an email. Okay, then I think we can start with the presentation. I will share my screen now. So hope you can see it. Yeah, as a manufacturer of components for industrial image processing components, our product portfolio ranges from classic 2D and 3D cameras to cameras with integrated AI-based image processing. That's why we also deal extensively with the topic of artificial intelligence and what possibilities it opens up, and of course, how can it be used? This also includes the field of quality assurance. When we as a camera manufacturer talk about AI and possible application scenarios, we are of course not referring to an autonomous acting AI like a human brain that can draw on every piece of knowledge ever learned and thus predict whether results are believable or unbelievable. Rather, it is about optimizing and supporting purely subtasks of the various production processes, such as visual monitoring and control of processes, reducing energy consumption through the use of embedded hardware, product testing and improvement, but also in the sense of predictive maintenance. In doing so, we build on the capabilities of current camera hardware, supported by possibilities of the ongoing digitalization in form of image data, which we can use to train the neural networks. And this enables us to provide the current machine-based industrial image processing with additional simple tools. We just call it AI vision. Because cameras today are capable of much more than just delivering image data, used as an embedded vision system trained by machine learning, they can take over many time-consuming inspection tasks from humans. And at the same time, the AI remains very simple, manageable, and controllable. Even so, the interest in artificial intelligence in image processing is high, very high. There are still relatively few productive applications. But let's not go into the reasons for this here as they would go beyond the scope of this presentation. However, to give you an idea of the tasks that an AI vision system in the form of an intelligent camera can take on or support today, here are some examples from our everyday life, from projects that show that cameras used correctly see more than human eyes, that machine learning is clearly suitable for taking over previously manual inspection tasks and support existing processes, but doesn't necessarily have to replace them, because machine learning cannot do everything. Okay, and we also see that tasks that were previously difficult to handle, for example, for classic rule-based machine vision, can be solved quite easily with machine learning. Here we see camera images of an application where rotating axles were secured with some snap rings. The task is quite simple. The ring must snap into the slot in the axle when it's mounted from above by pressure. And this is, if this is not 100% guaranteed, this can have serious consequences. And the problem is that up to now, no successful inspection solution could be found for exactly this reason. And so this quality check had to be ensured by humans at our customers until now. In tests with rule-based image processing, it was only possible to say the snap ring is present or it is missing. The best solution would be to detect whether the ears of the snap ring are more widely spaced, and yeah, then they should be. And then the snap ring might be in place, but not necessarily securely locked in. It could also lay on the top. A feasibility analysis in our AI vision studio, IDS NXT Lighthouse, showed that only a few image samples, in this case, that was just under 300, were sufficient to train a CNN in a short time that was able to detect the faulty seating of the snap rings quite well. This meant that all manual visual inspections was only necessary for very few uncertain results. With the testing and validation options, the trained neural network could be checked with images or of known error classes. Here, for example, you could see how good the separation between the different classes was. In this case, the variance of the good images was, or okay images here in the slide, was still too high. And according to overlapping error predictions, some false positives could still occur. But this can surely be improved by further training. Nevertheless, even with a relatively small number of training images, it becomes clear that AI vision is very well suited for this application. Attention maps are another tool that helps to visually recognize what the neural network's decisions and evaluations are based on by marking important pixel areas. And as expected, the neural network was able to identify and evaluate the relevant features of the known error classes and assign them to the different classes during the training. It was also interesting to see how unknown and therefore untrained error cases could also be sorted out. This shows that machine learning methods are also able to use more than the mindless trained knowledge of known features and can thus also signal unknown emerging problems. In this case, a blurred camera image caused by the attention map to mark deviations in several places. I can show you more about this in a moment with the other slides. Also, wood as growing raw material, which is therefore characterized by a high natural variance, is a good example where machine learning can be used effectively, regardless of whether it is for furniture construction, fully automated sawing of panels, or for the production of floor panels with a wooden look. The natural variance of the wood grain or the defects that occur during the growth, such as knot holes or cracks, make automatic machine quality defect checks difficult. The fact that something like this is difficult to describe or program rule-based does not mean, however, that camera-based image processing cannot perform effectively in such a case. Because even if the natural wood grain varies greatly, like a fingerprint, it has a clearly recognizable structure of lines, a pattern that can be well trained. And defects that cannot be assigned to this pattern can also be easily recognized as deviations. And especially in cases where such defects are not reproducible or defect patterns are rather unknown. And because of this, an imbalance between the normal or the good and the unnormal defect training data must be expected, then the machine learning method of the anomaly detection is a promising solution approach. And this without having to describe the deviation itself in detail. I would like to briefly mention another application that is associated with large or long inspection objects, the web inspection. Here, effective imaging is usually only possible with a line scan method. This means that in applications with continuous web inspection, for example, of textiles, paper, or silicon wafers, current AI vision cameras are often not suitable due to their area scan sensor. The image area is often not large enough to capture the entire analysis surface. And even with assisting lenses, a perspective distortion may occur that would first have to be eliminated before the processing. So, is it necessary to switch to a standard setup with a line scan camera and PC-based image processing for such applications? Does this mean that some new AI cameras like our IDS NXT models are already out? No. Thanks to a line scan mode, IDS NXT cameras that work still with an area scan sensor can also be used for many simple web applications. A single active sensor line can be configured in the center of the image to scan the objects. With a color sensor, such as in IDS NXT models, 2 lines are recorded and to calculate the color information. And then the active lines are joined together to form a complete image that is then analyzed by the onboard AI. And this allows also the inspection of rotation symmetric objects by virtually rolling off the outer shell and squaring it, for example, when you think for batteries, as well as metal tins and bottles. And with a simple setup and significantly lower system costs, an IDS NXT system is therefore also a cost-effective alternative to an original line scan camera system where AI vision is additionally to be used. Let's briefly return to the use of anomaly detection, because it brings another great benefit to quality assurance that is not easy to implement with a rule-based image processing. I'm talking about monitoring of the state of a system. With such a tracking, the degradation of a system can eventually lead to an unforeseen breakdown of the system. But if you had or have continuous data about this system state, for example, in form of the increasing product defects or deviations, anomalies, you could better expect or plan for this point of failure. And the crucial thing here is the ability to recognize every deviation from the normal case, including those that are underrepresented in the training. In other words, those that were not planned at all. So where other methods become uncertain, sometimes even fail with something unknown, nothing remains hidden from this method with a high degree of confidence. And that includes everything that can occur at some point in the normal operation. This makes the AI method, anomaly detection, ideal for early signaling of emerging sneaking faults caused, for example, by tool degradation, dirt, or other disruptive influences. Based on the increasing product defects and the defined tolerance limit, an optimal time for a system maintenance can be determined before the product quality drops too much, or a worst case scenario, such as a system breakdown occurs. Let's take a look at another application. These images show an inspection task that also can be easily and safely automated with AI vision. In the production of many such tilt lid bottles, the front side must be detected, as a correct bottle label may have to be applied on the matching side during the production. And here too, an effective solution with classical methods failed because no clear rules for feature identification could be defined. On the other hand, a simple classification by front-rear side with corresponding image material of the possible lid views deliver an almost 100% result amazingly quickly. For this test with IDS NXT, no feature had to be defined with rules, and not one single line of source code had to be written. The natural variance that we have just mentioned in the case of wood is, of course, also found in the agricultural sector, to touch on a completely different scope. Applications in which objects like vegetables or fruits are to be reliably detected and evaluated can hardly do without AI-based image processing. Under the buzzword smart farming, there are many tasks that can be solved today through AI vision, and therefore improve the yields as well as the product quality. In this area, we have already had to deal with the optimized application of fertilizers, the control of plant damage or pest attacks in general, and also the control of growth phases and the monitoring of the harvest stage. In this way, AI vision can also be used to realize much more effective crop tracking in agriculture. Tractors equipped with camera technology that have learned to the knowledge of farming experts can thus check how the plants are doing every time they drive through the field. But also with autonomously driving robots equipped with AI-based camera technology, a lot of studies and tests are carried out today in which we could already support with our components. Yeah, after this short overview of possible quality assurance tasks and projects that can be realized with machine learning and AI vision, and the decision to use machine learning, we must also be clear that image analysis with AI alone will not make the products better. It is not only about seeing and analyzing. The whole workflow is important of the application and has to be considered, where decisions have to be made and results have to be processed and communicated. And here we come to the question of what we offer as a manufacturer and for whom, because this technology must no longer be reserved for specialists. Everyone should be able to create his own AI-based image processing. Industrial experts know that the vision community of the future will no longer consist only of image processing experts anyway, but will grow from the IoT sector and new startups. And for this reason, in addition to the IDS NXT hardware platform, we also offer a completely self-developed software environment that covers the entire AI vision workflow. From the creation or training of a neural network to image data management with a suitable categorization of the image content, as well as the realization of the application software that later performs the inspection task on an edge device on which the application is fully optimized and works autonomously. And this also includes the maintaining and further development of the application later on. Our goal is to make AI vision accessible and easy to use for everyone with IDS NXT. Building complete applications should be possible for any user group, whether they are programmers, image processing professionals, or machine operators and technical staff. And with new user groups, other use cases and other requirements for the application of a technology automatically become necessary. The classic software development kit for programmers is no longer the right tool for everyone, and it's no longer sufficient to control the entire AI vision workflow. To bring raw image analysis and its results into productive workflow, further special expertise is usually necessary. And therefore, we have also established various options for all IDS NXT users here. For a quick entry into AI-based image processing and for target groups that are looking for ready-made applications or want to offer them, we provide VisionPeer, an online marketplace for ready-to-buy and ready-to-sell applications. You don't always have to rediscover the wheel. Often reaching for the shelf saves valuable time and money. The application wizard is a kind of guided setup that supports the selection and setup of the project. The user selects from a ready-made use case scenarios, and the wizard guides through the entire app creation process with simple queries and tips. And then we have the block-based editor. We offer a kind of construction kit to create your own workflows with predefined function blocks in a no-code environment. The advantage of such a visual programming over the wizard mode is possibly to create your own sequences with loops and conditional statements, or to use several, more than one neural network in one workflow. But also for code-based development environment, we provide experts with all the necessary libraries and tools to program IDS NXT cameras complete as an open platform. So you see, AI vision can certainly be used for many quality assurance tasks or can expand and improve existing applications. And there are already many ways to get familiar with the subject of AI. And even as an AI beginner or without much experience in image processing or application programming, after all, software and user-friendly interfaces can support a lot today. Nevertheless, you would like to know in advance whether your task can actually work with AI vision, even before you spend a lot of money and time on expert manpower, knowledge building, and AI systems to address the issue. Okay. At this point, I would like to mention our first Vision Challenge session in January of the new year. We will show you how you can take the initial steps to the first AI vision result without any hardware and completely free of charge and without any special knowledge about AI, image processing, or application programming. All you need is an account for our cloud-based AI vision studio, IDS NXT Lighthouse, which you can even use 1 month for free without any restrictions. We will go through the whole workflow together using examples. Afterwards, you will be able to evaluate your own task independently and see from the result whether the investment in AI vision hardware will be profitable for you. You can already register today in the Vision channel for this session. If you are already a step further and think about an AI vision system to get your first experience with an inference camera solution, you can take a look at our IDS NXT AI Starter Kit. It provides you with everything you need to get started right away. It gives you access to the complete software environment, including also the access to IDS NXT Lighthouse to extend your initial evaluations, refine the CNN training, and then run your image processing applications on the embedded camera hardware, which is also included with all the necessary components. This brings me to the end of my presentation. If you would like to learn more about application with AI-based vision, about the possibilities of testing the technology and integrating it to a production process quickly and with little time and expense, you will find further information on our website, more presentations about this topic in the Vision channel, and you can simply contact our sales colleagues directly. So then I would say thank you for your attention. And yeah, now it would be the time to clarify some questions. I will still be online in the next few minutes and will answer all your questions in the chat or in the Q&A section. I will then look if there are some of questions here again. Yeah, in any case, I would say I wish you a successful rest of the week and a peaceful pre-Christmas season. Then I would say here goodbye and see you again.